Hi students, today we are going to do some experiments with water. Please ask permission before you try this experiment at home. I would like you to try at least one experiment and show your results on Seesaw. If you'd like to do both, that's great. We will be using the aluminum foil from the bag that we gave you from Science and Art. Experiment 1. Sink or float. For this experiment, you will need something to hold water in, such as Tupperware, a bowl, a pot, or even your sink or bathtub. You will also need to gather 10 mystery objects around your house that are okay to get wet. Have a piece of paper or dry erase board nearby so that you can keep track of your data. Data is the results of your experiment. In this experiment, we want to know what objects will do in water. Will they float or go to the top, or will they sink and go to the bottom? I have my 10 mystery objects ready to test. But before I put them in water, I want to make a prediction. A prediction is my best guess. It's okay if I don't know. Scientists always think about what the experiment will do before they test it. So try to predict. Maybe talk to mom or dad or a sister or brother and tell them your guess before you actually put the objects in the water. You may use your data sheet to sort the objects. Sorting is putting the objects into piles depending on the question. Your question is, do they float or do they sink? Now that I've finished my predictions, I'm ready to test. I'm going to start with my sponge and gently place it in the water. I can observe what happens to the object in the water. Then pick a new object. Both the sponge and the ping pong ball are floating. They are on top of the surface of the water. I will continue to test all of the mystery objects until I have finished. I did pretty good predicting what would float. Now it's time to test what would sink. The marble went straight to the bottom. It sinks. The plastic toy that I thought would sink actually floats. It's okay to make a wrong guess. I'm learning. Wow, now that I've finished, I can see which objects float and which objects sink. But I wonder why. I'm going to go ahead and show you how to document or share this data. Each object will come out of the water and I will place it on my data sheet showing whether it floats or if it was at the top of the water or if the object sunk or went to the bottom of the water. Each object will either be on the floating side or the sinking side. Wait a minute! As soon as I touched the pipe cleaner, it sunk to the bottom. What's going on? How can something float and then sink? Let's take a closer look at the pipe cleaner. Pipe cleaners are made out of thin wire. They are very flexible, but they're also covered with fuzzy fabric. When I put the pipe cleaner in the water, the fuzzy fabric was dry and it floats. When that fuzzy fabric got wet, it caused the pipe cleaner to sink. I'm going to go ahead and put this one in the middle to show that sometimes it floats and sometimes it sinks to the bottom. Maybe you'll find an object like this in your testing. Now that I have finished, I want to look at all my objects and try to figure out why things float and why things sink. Do you have a guess? When you see your results for your float or sink experiment, you might notice that objects float if they have air trapped inside them. Both the sponge and ping pong ball hold air inside them. The marble and the crayon, however, do not have air inside them, so they sink. Gravity is still acting on objects in water, but if they have air trapped inside them, they are buoyant. A buoyant force is pushing in the opposite direction of gravity. We can experiment with buoyancy in our next experiment. Experiment 2. Build a foil boat. You will need the aluminum foil that we sent home in your Science and Art bag, a plastic tub or container for putting water in, which could also be a sink or your bathtub, and also something that you have a few of at home, maybe coins or small toys. For this experiment, I'd like you to try to make a boat. Using the aluminum foil, you might want to frame the boat around a small plastic cup. This is to help you get a shape of a boat. You then want to make sure you take the plastic container out. Don't test the boat with the plastic inside, because that's not a boat that you made. Your cat might enjoy this activity. Make sure the sides are nice and high. We don't want the water to get inside our boat and make it sink. We have to trap a lot of air inside that boat to help it float. If you have extra aluminum foil at home, you can try many different designs. Try to make the biggest boat or a rectangle boat. How many different boats can you create? We will then test the boats to see how much weight they can hold. When you're ready to test your boats, put some water in a container. See if your boat floats. Hooray! If it floats, you're ready for the next test. How much weight can your tinfoil boat hold? You may test this by using coins or small toys that you have around your house. One at a time, add a coin or a toy. Check to see that the boat is still floating after each amount of weight is put inside. Keep counting. How many pennies or toys can your boat hold? I would love for you to share with me on Seesaw the boat that you made and your final number of toys that you could hold in your boat before it sank. With my second boat, I tried adding Lego figures. I got up to 29 Lego figures before my boat sunk. My best result, 29 Lego figures. So what makes the foil boats float? Remember, air is important when you're trying to make a boat buoyant. You want it to float on the surface of the water. Gravity's still pushing things down, but that strong buoyant force will push up. If you flattened out your foil, I don't think it would float very well. There's no more trapped air. So designers of boats need to think about how much air they can trap inside their boats. I hope you had fun designing boats and testing them to see how much weight they would hold. Science is all about trying, testing, observing, and then trying again.